And now onto the color management in the context of photogrammetry. It may seem off tangent at first, but it's super relevant. The basic premise is that the naive approach to color management, for example, letting the camera decide on what format and what color science to use and whatever, may lead to the colors that are off, the contrast that is broken, and so on and so forth, while the correct color management pipeline guarantees the correct colors that are close to the reference and many other benefits that you love. So let us get started. First, let us talk about the in-camera JPEGs, aka the display-referred disaster. All of us remember the camera settings that may look like this. Picture profile set to Creative Pro look, there's the word gamma somewhere, some kind of a LUT applied to image, and the file format set to JPEG. And sometimes we just don't give these things proper attention in photogrammetry, we just snap photos as if there is no tomorrow, then save everything to JPEG, because that was the default setting on the camera, and drag it all into reality capture or other photo scanning software, let it do its job, and unsurprisingly it results in the acidic looking and pretty bad looking texture of our photo scan. And unfortunately that's only the half of the problem. We'll see in a moment what's the rest of the problem, but for now let's try to decipher what actually happens when we follow this color management pipeline. So what does actually happen with what we called the naive color management system, or how the ground truth gets distorted? First of all, we have some real-world environment that we take the photos of, aka the ground truth. Then the light from this environment hits the camera sensor. The light that reached the camera sensor gets recorded. It is recorded as pure intensities and gets its color data from the Bayer pattern. We won't go into these details just yet, let's just mention that it's saved linearly, without any perceptual curves and other effects applied. It's saved in a physically based way, as it is. And then if the in-camera based processing happens, usually the base curve or the contrast curve is applied to this data. It already makes it stray from the physically based representation that was recorded by the sensor, and then it gets even worse with the creative color tweaks put on top of it. And then, depending on the device, even more creative color tweaks can be applied to it, especially if it's a smartphone. It's surprising how skewed the colors may become after all the processing. And then it's all saved to JPEG, which is a compressed format. And after all these manipulations, we can practically no longer reconstruct the light that hits the camera sensor to know how this original scene looked like. This type of approach to the image creation pipeline is called the display-referred approach, and so we get the display-referred texture. The display-referred images are meant for presenting on display, not for using them as textures. And so when this image is used as texture, we apply some kind of secondary processing on top, be it a filmic color management, a contrast curve, or anything of that sort, and we get the double processing effect. We get nuclear oversaturated colors, crazy levels of contrast, and generally not very pleasing look in the end. And what's even more important, we get the colors that are no longer representative of the original environment. The other type of issue with the display-referred texturing is that we can no longer align the images from different devices properly. They will have different tint, different contrast levels, so on and so forth. So where is the way out of this color management hell? Well, we can start by using the raw photos or digital negatives, preferably with a color checker. It will be the scene-referred approach. So we have some kind of a scene or environment. The light of this environment hits the camera sensor and gets recorded linearly. Then we try to get back or to decode this light with applying some white balance and exposure tweaks in the meanwhile to get as close to the original environment in terms of colors by using the color checker to prove ourselves as possible. So what we do, in other words, is that we decode the scene-referred values based on the information from the sensor. So with this scene-referred workflow in mind, the process could look like that. First we snap the raw photos, which are at the same time uncompressed. And then we develop them into images in a special software like Darktable or Lightroom, the software that can deal with the digital negatives. Later in the course, we will walk through all the steps of utilizing Darktable to develop raw images together. But for now, let's just say that in Darktable or any other software of that sort, first of all, we try to disable the base curve or the base contrast. We can do stuff like that, like linearizing the base curve only in post and only with the raw images. Because by default, when the camera uses the format like JPEG and bakes all the processing into the image, it applies some kind of a base curve that is associated with that camera model. And after such curve is baked, there is practically no way back. It is very hard to unroll it. What does this curve alone do to the colors? Well, it makes pretty much all the values of the swatches of our color checker off. We have the CIE reference of the color checker passport values somewhere, so we can always compare against it. But for now, let's say that all the values will be slightly off, and the relationship between the brightnesses will also be broken. There are obviously other types of modules or effects that can be turned off in post when dealing with the raw photos. The Filmic RGB display transform can be also turned off. It also has a built-in curve. So if we want to decode everything to its initial state of the light that hit the camera sensor, we can just disable all the extra effects, as simple as that. The only two necessary manipulations that we should do with our raw source is choosing the right color temperature and exposure, and that's it. Actually, I think that makes the entire scene referred workflow very straightforward. First, we define the color temperature of the scene illuminant, which can be done with the help of the color checker. Here, for example, it should be set to approximately 8K Kelvin. And then we just try to nail the exposure. So, for example, if we color pick the white value or the D1 here, we should make sure that after adjusting the exposure, it's around 96, where 96 is the first value of the lab color space or lightness. And we can check in the reference file, which is the color reference of this color checker, that indeed the white swatch should be around 96. And the neutral gray should be what? Around 50, which makes sense, it's middle gray. In the lab terms, it should be dead on in the middle. So 50, where's the middle gray? Let's see. It corresponds to the reference values, so we know it should be correct. So if our camera is more or less calibrated, the white balance set correctly, the exposure set correctly, all the values should now correspond to their counterparts in the reference file. So that's as close as we can get to the ground truth, and that's with using the raw files. It's not a big deal if we don't have a color checker around. We can use a gray card instead, which is fairly affordable. It provides a nice reference of a color temperature within the scene. And if we got nothing of that sort on making photoscan, we still have some neutral surfaces, which we believe are the neutral gray or white. And we can use these surfaces to eyeball the color temperature. Usually it works pretty well. So that was the scene-referred workflow as opposed to the display-referred workflow. With this workflow, our intention is to get the colors that are representative of the original environment. And we do it by properly decoding or processing the raw files. As opposed to how the display-referred textures broke after applying extra processing in Blender or in any render engine, the scene-referred textures behave correctly. Basically, no matter what we do, even after applying the very high contrast or any kind of filter, it will look all right. There is no crazy color tint, the white balance was set correctly, the brightness of the albedo is correct, we'll talk about that later. And as an extra bonus of the correct color management pipeline, we can process the files from different devices and pretty much line them up in terms of colors. So if you, for example, used a drone, a camera of one type and a smartphone shooting in RAW. Now you can pre-process the sources in such ways so there are no visible seams in the photo scans. That's great. That is pretty much it for this tutorial. Thank you so much for watching. In the next one, we'll carry on talking about the color management pipeline, though. To be exact, we'll review two types of photo scanning workflows in relationship to texturing. The first one that deals with the pure light values or material emission, and the second one that deals with the PBR or physically based rendering based materials.